Hello everyone! In the video of today I want to show you the methodology how to part precious metals. When I'm talking about precious metals, I mean gold, silver, platinum, palladium, iridium, ruthenium, osmium and rhodium. The first step is to digest that stuff in aqua regia. Therefore we have to prepare aqua regia, and this is generally prepared by mixing 1 part of nitric acid and 3 parts of hydrochloric acid. So you mix it, you put it in a vessel under a fume hood, you put the metals inside, be it in a form of granulate or powder or whatever, and then you boil it. And the next step, once everything has reacted, is to get rid of the nitrates. So getting rid of the nitrates, it's pretty easy. You just have to evaporate everything down to a syrup-like consistency. So not to dryness, just to syrup-like consistency, under a fume hood of course. And then refill it with hydrochloric acid and boil it down again. So you have to do these evaporations 3 times. So always refill it with hydrochloric acid, evaporate it down. Refill it with hydrochloric acid, evaporate it down. 3 times in order to get rid of the nitrates, because they would interfere with the process further on. That's why we want to get rid of the nitrates. Once this is done, at the final evaporation, when you have the syrup, you add distilled water, about 4 times the quantity of the syrup that you have left. And then we come to the last stage of the first step. It's the filtration. So once you have added the distilled water, you perform a filtration. Doesn't matter if it's vacuum filtration or something else. And this will leave you with 2 things. First of all, you will have a residue on the filter, and then you will have the solution. And the residue on the filter will be iridium, ruthenium, osmium, rhodium and silver chloride. Whereby in the solution will be gold, platinum and palladium. So this is the first step, and now we're moving to the second. Now we're in step number 2. So we're starting with the solution that contains the gold, the platinum and the palladium. The first thing that we are going to do is to add sulfur dioxide gas. So basically we are bubbling the gas through the solution. This operation will precipitate the gold as a brown powder. The next thing here is to filter the precipitate, wash it and add the washings back to the mother solution at this point. So here our gold is already out. The next thing is we are adding a saturated solution of ammonium chloride. This ammonium chloride will precipitate the palladium as ammonium chloroplatinate. This is an orange powder. We do the same thing with the filtration, so we filter out the orange powder. We wash it and add the washings back to this point, to the mother solution. In order to reduce the ammonium chloroplatinate to platinum, we have to do a hydrogen reductions. This is very easy when you have a tube furnace. You put the ammonium chloroplatinate in a crucible, you add it in the quartz tube, you create a hydrogen atmosphere, and then you heat it up about 500 to 700 degrees. This will reduce the orange powder, the ammonium chloroplatinate, to platinum sponge. Okay, let's move on. At this point we just have the palladium left. In order to precipitate the palladium, we add sodium chloride crystals. And when we add these sodium chloride crystals, The precipitate will be palladium ammonium chloride, which is a red powder. And in order to reduce this red powder to palladium, we do the same thing. We do a hydrogen reduction in order to get the palladium sponge. This was step 2. Now we're in step number 3. In this step I will detail how to get the silver out. So we start with the residue of step number 1 that contains the iridium, ruthenium, rhodium, osmium and silver. We take the residue and we smelt it in the crucible with lead. Then, with the smelt, we perform a granulation. This is done to increase the surface area, to make it easier in the next step for the acid to attack the material. The granulation is done by simply pouring the molten metal into water. Okay, once we have the granulate, we digest it in nitric acid. And once the digestion is done, we dilute it with distilled water. Then we perform a filtration. From the filtration, we will have a residue, and this residue will contain the iridium, the osmium, the ruthenium and the rhodium. And in the liquid part, we will have the silver. Of course also the lead, but the lead is not interesting to us. We want the precious metals. And now in the liquid we are adding hydrochloric acid. The hydrochloric acid will precipitate the silver as silver chloride, because silver chloride is not soluble in water. It's a white powder. Then we can filter the silver chloride and again perform a hydrogen reduction to get the silver. So now we are in step number 4, and in this step we are dealing with the rhodium. You remember from our last step, we have the rhodium, osmium, ruthenium and iridium left, the residue. Now we take that residue and we fuse it with sodium bisulfate. So that means we take a crucible, we add that stuff, we add sodium bisulfate, we heat it up till about everything is molten, about 1200 degrees. We fuse it for a couple of minutes and then we let it cool down. Then we grind it in an iron mortar. And then what we have grinded, we dissolve in distilled water. And then when it's dissolved, we perform a filtration. And then again we have a residue and a liquid. Now the rhodium is now in the liquid form. Yeah? And the residue is iridium, osmium and ruthenium. To this liquid here we add a solution of 2% barium chloride. Then we bring the solution to a boil and boil it for several minutes. This will form a precipitate. This precipitate in the solution we will allow to cool down. Then we perform a filtration and wash the precipitate with hot water plus 2% barium chloride, and then we wash it with distilled water. And then we take the precipitate and digest it in 1 part hydrochloric acid and 3 parts distilled water. We bring it to a boil till everything is dissolved, and then while it's still boiling we add hydrogen sulfide gas to the boiling solution. This will precipitate rhodium sulfide. The rhodium sulfide precipitate we wash with dilute ammonium chloride. Then we take the precipitate and perform a hydrogen reduction on it to get the rhodium. Now we have the rhodium out. Now we are in step number 5. In this step we are dealing with the iridium. So from our last step we have the residue of iridium, osmium and ruthenium. We take this residue and we perform a fusion with 50% of potassium hydroxide and 50% of potassium saltpeter. The fusion is done in a cast iron crucible at a temperature of about 700 to 800 degrees. And once the fusion is done, we dissolve everything, we dissolve the fusion in distilled water and perform a filtration. The filtration will again yield a solution. The solution will contain the ruthenium and the osmium and the residue. The residue in this case will be iridium oxide. The iridium oxide we take and dissolve it in aqua regia. To this liquid we add ammonium chloride. The ammonium chloride will precipitate iridium tetrachloride. The iridium tetrachloride is not soluble in water. We filter it off and we will perform a hydrogen reduction to get the iridium. So now we are in part number 6. That's basically the separation of ruthenium and osmium. One word to this operation. I have personally never done this separation of ruthenium and osmium because working with ruthenium and osmium, especially when they are in their volatile form, it's very dangerous because especially osmium and osmium tetraoxide, they are inherently toxic. It's a very potent carcinogen, it's very toxic, and I don't want to mess around with that stuff. So while I can say from a personal experience that all the other parts of parting, it's working, it's good like that. Here I don't have personal experience, but still I will give you the theory. The theory is basically that you take the solution of ruthenium and osmium ions and you perform a distillation on them up to red heat is achieved. So when you make this distillation, the residue will be the ruthenium and the distillate is the osmium tetraoxide. And on the osmium tetraoxide, that's the really bad toxic stuff, you can again perform a hydrogen reduction to achieve or produce the osmium. Finally, I want to talk a little bit about safety in this entire operation. In general, when you work with all these strong acids, you really need a good, proper working fume hood. And it's highly necessary that you protect yourself, meaning you wear gloves, you wear eye protection, even a face shield, or just keep care to really protect yourself. Further on, I want to outline some dangers here, especially when you want to work with ruthenium and osmium. These two metals in their volatile form are very toxic and very dangerous, especially osmium tetraoxide. It has a garlic-like smell and it's a potent carcinogen and it will cause blindness. So that means when the fumes come into contact with your eye tissue, it will reduce to metallic osmium and that will in turn cause blindness. So really either don't work with that stuff or take the utmost care to prevent any accidents. Additionally, you should take care about the lead fumes. So when you perform the lead fusion, you really have to have a good ventilation, because lead fumes are very bad for you. So take care for good ventilation and don't breathe in any lead fumes. Another danger is rhodium in the ionic form, especially as a chloride, is also very dangerous and toxic. So it can cause a blood poisoning. Even when you get it under your fingernails, you will have a blood poisoning. So really take care also when working with rhodium in the ionic form. And the last dangerous operation is the fusion with the potassium hydroxide and the potassium saltpeter. This is kind of a very reactive substance, potassium saltpeter. So when you do the fusion, make sure that you are not close to it in the case it blows up. It should not do it, but just to be sure, you know. Yeah, that's it. I hope you liked this video, and if you decide to part some precious metals, good luck.